Uh, this will be weird, but I woke up wondering to myself, why the obsession and energy and effort, and I don't know. I tried to explain it to myself, and when I was done, I thought, maybe I should capture this. Who knows? Rat Rail Line was a name I gave to my trains because I don't like to paint, so everything looked ratty. But I wanted them to be cool. And there were some engines that had smoke and some that didn't. And so this whole notion of smoke and 4 chuffs per rev and all that just became obsession, I suppose you could say. The good old standard smoke system that we have from the vintage Flyer is a cast pot metal housing that has a heater coil pushed by a piston and driven by a gear, and that gear was 1-to-1 to the drive wheel, so we got 1 puff and 1 mechanical chuff sound per revolution, which was pretty good when you're running the engines at a speed of 120 scale, which is what you had to do to get these things to sound and feel good, but they were going by so fast you really couldn't see them or enjoy them. Then digital technology came about and people started putting digital motors on everything. They put digital motors on the fans that drove the smoke. Now you could control the smoke independent of the mechanics, so we could get 4 puffs or 2 puffs per revolution, and you could time that with a digital sound card, and it was pretty exciting. So some of us went out and bought these units from Lionel and Mike's Train House, and we put them in our engines at great cost to the integrity of the engine, because a lot of things had to be cut and chiseled away to make room for the motors that would hang down and the PC boards that were required to run it, and it just sort of got nasty. And it struck me that, well, looking at this thing, it's really not a bad design. I just want to replace that piston. So I came up with some ideas. I thought, well, if I took their fan thing and copied that into a cylinder that would slide into one of these things, I could mimic this fan into a vintage smoke and connect it with a tube, and had to move that. So I did. I built several of these, installed them, and they actually worked. Copper tube connecting, fan blowing the air in, heater and everything was identical, and I could pulse the motor with a trigger of some kind. Normally we're using a reed switch off of a wheel in the tender. I got more sophisticated later, but we'll get to that another time. And I went through a couple of designs like that, and then I realized I cannot continue to cut up these housings. One, I'm running low on them, and 2, they're actually vintage. I mean, if someone really wanted to restore it and put it in his train, he couldn't, because I've used them up. So I thought, I had this little 3D printer. Let's see what we can do with a new design. Maybe something else. I wasn't sure. What could I come up with? What could I even do? So I threw one together, I fitted it up, and it worked. But of course, this was my first ever 3D printed design, and it wasn't really made to fit anything. It was just made to see if I could do it. So over time I refined the concept, made some modifications here and there, made other improvements, and downsized as I went along, until I realized once I put the motor on this thing, I'm right back where I was with the interference and how's it going to fit, and I couldn't make it small enough. I went through a couple of other iterations trying to be elegant, giving it mountings and making it thinner, but in the end what happened, it just got bigger and bigger and bigger, and I couldn't even assemble it. So then I went back to the drawing board, so to speak, and I looked back at my unit here, and what I saw was I'm intaking the air from the top into this chamber. So I took this hole here and I made it on the sides, and then I took the outlet hole and I connected it with this tube to the outlet of the stack. So I thought about, can I do that in this same fashion, in this linear fashion? Can I just make this box bolt right on here, build something that actually, and then build this and just make the whole thing? So I took a couple of my designs and I cut them up. I cut one of these in half. I turned the housing on its side, I glued it together, I put spacers in there, I gave air underneath to the center hole for inlet. The copper tube blew the smoke out. I put a heater in there, and by golly, it smoked. It smoked, and right up until it melted, it got hot. Okay, so not such a good idea. But the concept of this side vent fan seemed to have legs. So I designed up a single piece with two holes. The center hole pulled air in from the side. The upper hole blew the air down to the smoke, and the fan and the motor fitted into that. And it fitted into that, bolted to a plate. So it would just bolt in. I went to a more complete design here, trying to mimic everything that I had before, and still had the heat problem, but I thought if I lined it with metal, maybe that would help. I found out that it did not. It was still melting. But for short bursts, I could put the fan motor in, I could fire it up, and it would do the trick. So I knew conceptually I was in good shape, but the temperature is the issue. I started researching materials, seeing what else could be found, and indeed there were other materials. Meanwhile, while I let the material search cook, I continued to build test pieces which I could run for short periods of time. I got frustrated waiting for the materials to come in, so I did the unthinkable. I cut off the round piece here. I cut the round piece off, and I took the front half of the smoke housing and adapted the back half of my fan smoke system, and I tried it, and it worked, and it didn't overheat, it didn't melt the plastic because the plastic was far enough away from the heat source, and it gave a good plume of smoke and was quite effective. Now how can I get rid of this? I don't want to cut up many more pieces. I went back to my old sources of Lionel, and I found that there was one Lionel unit that had a separate box for the heat core. I took that separate box and I rebuilt this idea using the back end of a newer unit and the front end of a newer unit, and I put the heat box in the middle, metal, and it works. This particular model leaks because it has vent holes that I didn't plug, but I'm convinced this is the answer. This is where we're going. All I need to do now is come up with a material that's heat resistant